Unit 6 Shapes. Parallel lines and transversals. As you can see from the two green dots, alternate interior angles are congruent. The two orange show that corresponding angles are congruent. The two red show that same side interior angles are supplementary. And the two pink show that alternate exterior angles are equal. As you can see from these four problems, they're examples of how to prove each theorem. Properties of parallelograms. They have two sets of parallel sides, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, and diagonals form the two congruent triangles. Properties of a rhombus. Properties of parallelograms are included: four congruent sides, diagonals bisect angles, and diagonals are perpendicular to each other. As you can see from this problem, it proves that all the sides are equal to each other.
Properties of rectangles. Properties of parallelograms are included. There are four right angles and diagonals are congruent. This equation has no answer because negative 44 is an extraneous solution. Properties of a trapezoid. There are two types of trapezoids, regular and isosceles. In a regular, there is one set of parallel sides, and the midsegment formula, base 1 plus base 2 divided by 2, can be used to find the average of the two bases. In an isosceles, there is one set of parallel sides, congruent base angles, congruent legs, congruent diagonals, and opposite angles are supplementary. This diagram shows you where each part of the trapezoid is located. Properties of a square. Properties of parallelograms are included, along with properties of a rectangle and properties of a rhombus. This equation is used to show that leg AE is equal to AC when it is doubled. Proving parallelograms. Figures can be proven to be parallelograms with the slope, midpoint, and distance formulas. The midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2 written as a point and can be used to prove that diagonals bisect each other. The slope formula is y2 minus y1 and x2 minus x1 and can be used to prove that sides are parallel. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared and can be used to prove that sides are congruent. Proving a pair of sides are congruent and parallel also proves the shape is a parallelogram.
Conclusion. In this presentation, we covered properties of parallelograms, squares, rhombi, rectangles, and trapezoids. Parallel and transversal lines, along with proving parallelograms using coordinates, were also covered. Contributors to this project were Evan, Alicia, and Sam.